Hkdse Physics 2020 structure question 1. So now we are making some wontons in soup by putting 5 pieces of cooked wonton at 4 degrees Celsius into a bowl of hot soup with 0.6 kg of soup at temperature 96 degrees. Okay, so some data are given here. We know that each piece of wonton is 0.02 kg, so we have 5 pieces of them. So altogether we have 0.1 kg of wonton, and mixed with the hot soup with 0.6 kg and at 96 degrees. So we assume they mix up together and becomes a mixture at temperature T. Assume there is no heat loss to the surroundings. Heat loss by the hot object will be equals to the heat gain by the cold object. So we can write that MC delta T of the hot object is equals to MC delta T of the cold object. So we can put in the numbers. And for the soup, the mass is 0.6. For the soup, the specific heat capacity is 4,200, just like water. The temperature change from 96 degree to T degree for the soup, so the delta T is 96 minus T. So on the other side, for the wonton, cold wonton, the mass is 0.1. And for the specific heat capacity of wonton, okay, it is 3,300. The temperature of wonton changed from 4 degree to T degree. So T minus 4. So we can simplify it. On the left hand side, we have 2520 times 96 minus T. So on the right hand side, we have 330 bracket T minus 4. So we have on the left hand side 241920 minus 2520T. And on the right hand side we have 330T. So we have 1320. And then let's put the T's together. On the right hand side we would have 2850T. And on the left hand side we have 243240. So finally T would be equals to 85.4 or 334 it should be. So 85.3 degrees Celsius. So part B. Soup in part A is taken from a metallic container of heat capacity 2000 joule per degree Celsius. So it contains 16 kg of soup. 16 kg of soup. Maintained at 96 degrees by immersion heater. What does that mean? That means in order to keep it at 96 degrees, I have to insert a heater and keep it at 96 degrees. Why? Part 1 asks you to explain why. It is because for this bucket or container of soup, it is maintained at 96 degrees, so it is hotter than the surroundings, which maintains at room temperature, so we can expect there is heat loss. So energy will be lost gradually. So if we don't input energy, the temperature will drop. So if you want to maintain it at 96 degrees, you have to give in energy. You have to supply energy. So energy is supplied to compensate for the heat loss to the surroundings. And that's why. So part 2. Students use the following method to find the heater's operation power. This heater operation power. Okay, I want to know its power. So what did he do is that he removed the heater. So no more heater. Oops. Like this, no more heater. And so no more heat supply. Okay, so energy will be gradually lost. And after 10 minutes, it's found that after 10 minutes, the 16 kg of soup, the temperature has dropped for 9 degrees Celsius. So why the temperature drop? Because of the heat loss. So we can calculate for the rate of heat loss by mc delta T over T. So mass of the soup, wait a moment. Besides the soup loses energy, the container also lose energy. Okay, so the container, remember, okay, it has a heat capacity of 2000 joule. Okay, so we have to take that into account as well. So besides mc delta T of the soup, we also have to take into account for the container. So mass of soup is 16 kg. Specific heat capacity of soup 4200. Delta T because the soup has dropped for 9 degrees, so delta T is 9. Container has a heat capacity of 2000. Delta T is also 9. Time use is 10 minutes. So we have 10 times 60. Change it into second. So finally, this would give us 1038 joule per second. That means this is the rate of energy loss due to the temperature difference. Rate of heat loss, 1038 joule per second. In order to compensate for this energy loss, we should have a power of the heater also equals to 1038 joule per second. Or you can use watts. So that the heat loss will be completely compensated. So the soup can be maintained at the same temperature, 96 degrees. Part 3. If the students repeat the measurements after another 10 minutes, would the corresponding temperature drop be larger than, equal, or smaller than 9 degrees? Okay, what is it saying here? It's saying originally the soup is 96 degrees. We know that after 10 minutes, the temperature decreased 9 degrees, so it becomes 87 degrees. The question is asking if we go 10 more minutes further. This time, would the drop be 9 degrees or more than 9 degrees or smaller than 9 degrees or exactly equals to 9 degrees? Okay, I want to find the temperature drop. Okay, so as you know that at first the soup is maintained at 96 degrees, so it is much higher than the surrounding temperature, which is room temperature 25 degrees. So therefore energy will be lost to the surroundings. Therefore we will have a temperature drop of 9 degrees. But after 10 minutes, the temperature of the soup already becomes 87 degrees, while the room temperature is relatively stable, doesn't change. So after 10 minutes, you'll find that the difference in temperature between the soup and the surroundings becomes smaller. That's why the energy would be released at a lower rate. Therefore, we know that the temperature will be drop for less than 9 degrees. Okay, so there will be not such a big drop in the temperature. So as the temperature of soup drops, temperature difference between the soup and the surroundings becomes smaller. As a result, the temperature drop also becomes smaller because heat is lost at a slower rate.